Hi, Miss Marion here. We are doing Unit 2, Lesson 5. So go ahead and take your workbook, open to page 119. That's in the back, right? And we are going to read the I can statement for Lesson 5. So I can apply dilations to polygons on a rectangular grid if I know the coordinates of the vertices and the center of dilation. So go ahead and give yourself a number, how you feel about this. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. 4, I can teach it to my friend. So go ahead and go through that. And also give your sentence about that number, how you feel about how this goes. All right, next, let's turn to page 43. Okay, so on page 43, it says all of the triangles are dilations of triangle D. I'm going to go ahead and highlight that, triangle D. The dilations use the same center, P, but different scale factors. What do triangles ABC have in common, and what do triangles EF and G have in common? What does this tell you about the different scale factors? So go ahead and answer that question, and you're going to write the answer on page 43. All right, so this is the answer that I got. I looked at triangle ABC, so these are my answer right down here. Triangle ABC, they are similar and closer to P than triangle D. And then EFG are larger and farther away from P than triangle D. So these are smaller and these are larger. So here the scale factor is going to be smaller. Here the scale factor is going to be larger. All right, so we're going to go ahead and we're going to go through some examples of dilating a picture on a grid. And you should have a paper just like this. It has example 1 and example 2 on it. And we're going to be using this. So we're going through 2 examples. So we're going to do example number 1 on 1, example number 2 on 2. All right, so let's start with example number 1. So I'm going to ask you to go ahead and dilate this picture. But I know you're like, hey, Miss Marion, we don't have something to dilate. All right, so I'm going to go ahead and I'm going to give you some points. So point A is 0, 6. Point F is 6, 0. Point I is 0, -6. And point D is -6, 0. All right, so let's go ahead and let's plot these points. So A is 0, no side to side, go up 6. Here is A. F is 6, 0, so we're going to go to the right 6, not up. Here's F. And then we have I, 0, -6, so don't go side to side, but go down. Here's I. And D is -6, don't go up and down. Here is D. So this is the picture that we are going to go ahead and dilate. Okay, dilate it. All right, well, you're like, okay, Miss Marion, I need some more information. So remember with dilation, there are a couple of things we need. 1, we need the picture. 2, we need a scale factor. And for this picture, it is 1/2. And we need a center of dilation. And that is 0, 0. So we're going to go ahead and we are going to dilate this. So this is our scale factor. And what we want to do is we want to count from our center of dilation and we want to do our scale factor. So going from our 0, 0 to F is 1, 2, 3, 4, 5, 6 steps. And we're going to take those steps and we're going to multiply it by our scale factor. So F is actually I. So we're actually going to take our 6 steps and we are going to multiply it by 1/2. Grab your calculator. 6 steps multiplied by 1/2 is going to be 3 steps. So from our 0, 0, we're going to go out 3. So 1, 2, 3. Here is our F prime. Let's go ahead and let's do that with A. A, how many steps from 0, 0 up to A? It's 1, 2, 3, 4, 5, 6. Okay, so we're going to kind of do that same thing. We're going to take our 6 steps, and we're going to multiply it by 1/2. Grab a calculator. 6 steps multiplied by 1/2 is 3 steps. So from there, we're going to go up 3. Here is our A prime. Okay, go ahead and try that with I and D. Figure out where I and D are going to sit. So I is 6 steps down. Now it's going to be 3 steps. Here's I prime. D steps is 6 steps to the left. Multiply by 1/2 is 3. So here's D prime. So this is our dilated picture. Center point is 0, 0. And our scale factor is 1/2. So all of this should be on example number 1 on that page. So again, here is our answer. All right, we should be on example number 2. So again, I want you to go ahead and dilate example number 2. You're like, but Miss Marion, we are missing some stuff. We need our points. Okay, so let me give you some points. So O is at 0, 0. N is 2, 2. P is -4, 0. And Q is at 2, -2. All right, go ahead and plot those points. So pause and plot those points. All right, so here are our points, and I'm going to show you how to connect them together. So P to N, N to O, O to Q, and P to Q. So this is our picture. Okay, go ahead and dilate. You're like, but Miss Marion, we need a scale factor. Our scale factor is going to be 3/2. Okay, but remember, you need a center point of dilation. This is going to be different. A center point of dilation, you should be writing this on your page also, is -4, 0. So that is our center point of dilation. Our center point of dilation is actually P. So what we're going to do is we're going to look, and we're going to go from P to N. We went 1, 2, 3, 4, 5, 6 to the right. So we went 6 right, and then we went 2 up. Okay, grab your calculator. We're going to take these and we're going to multiply them by 3/2. Okay, grab your calculator. Let's multiply those together. So we have 6 times 3/2. That is 9. 2 times 3/2. That should be 3. So we're going to go ahead and we're going to go 9 right, 3 up. So again, we're going to take it from our center point of dilation, which is -4, 0. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right, and then 3 up. 1, 2, 3. Here is N prime. Okay, let's try that with Q. So let's go ahead from P to Q. We went 1, 2, 3, 4, 5, 6. Sorry. 1, 2, 3, 4, 5, 6 to the right. So we went 6 right, and then 2 down. Again, we're going to multiply those. We're going to 6 to the right times 3/2 is 9 right. 2 down times 3/2 is 3 down. Okay, so from our center point, a dilation, which is P, we're going to go 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 down, or so 2 down. Oh, we're going 3 down. That's actually going to be here. So here is Q prime. And then let's look at O. From P to O is 1, 2, 3, 4. and it's only 4 right. I'm going to put that in blue. Hold on a second. So 4 right. We're going to take that, we're going to multiply it by 3 halves. So 4 times 3 halves. Well, that's 6. So that means we're going to go 6 right. Okay, let's do that from P. 1, 2, 3, 4, 5, 6. This is where our O prime is. And let's dilate P. So P is actually at our center point of dilation. It's not going to move. It's not going to move at all. So let's go ahead and let's combine these together. You should be doing this on your page. So technically P and P prime, they're the same. And then N prime to O prime to Q prime, and P prime. Oops, let's try that one more time. So this here should be our new picture, is this pink one. So we did a center point of dilation different than 0, 0, which is negative 4, 0, and with a scale factor of 3 half. So again, this is what our picture should look like. Take this picture, fold it hamburger style. Where are we going to tape it? On page 44. So go ahead and pause, tape that in, and then we'll show you next what we're doing. So all the information that we need to dilate a polygon can be communicated with numbers on the coordinate plane. So it's kind of like points on a grain. So just like an address, like to your house, coordinate planes actually give us the dilation as far as what we need to go ahead and do. Go back to page 119. Let's read the I can statement again. I can apply dilations to polygons on a rectangular grid if I know the coordinates of the vertices and the center of dilation. So again, this is what we did. Give yourself a second number. So 1 I don't remember, or kind of got it. 2 I did get it, or 2 I kind of, so 1 I didn't get it whatsoever. 2 I kind of got it. 3 I did get it, and then 4 I can teach it to my friend. And then today we are doing lesson 5, practice problems, and again put into Canvas. All right, have a good day. Bye.